Now, the light from all those distant galaxies was all redshifted, but by different amounts. And what that means is the more redshifted it is, the faster that galaxy is moving away from us. And we have an equation that links those things. So we have something called the Z parameter, which we just use the letter Z to denote. And it really is just the ratio of how much it has been redshifted, the difference between the wavelength that we would expect to detect and when we do detect, divided by the wavelength that we would detect from that same line, say absorption line from our star, the sun. Now we can do that with wavelength or we can do it with frequency. It doesn't matter. We get the same Z parameter from it. But that ratio is the same as the ratio of the recessional velocity to the speed of the wave. Okay, so the speed of light in this case. We can best show this through an example. So if we look here, it says an emission line from a star in our galaxy is given as 660 nanometers. So, whoops, lambda in this case is 660 nanometers. The same line in a star in a distant galaxy has been redshifted to 750. So we'd expect that line to be at 660, but because it's moving away, it's got a larger wavelength. Now that means the difference between what we would expect it to be is the 750 minus 660. So our delta lambda is, sorry, I've typed that in my calculator wrong, minus 660 gives us 90 nanometers. And the question first asks us to find the Z parameter. So the Z parameter is just the difference between the two wavelengths divided by the wavelength that we would expect if the source wasn't moving. Okay, i.e. what we would get from a star in our galaxy or from the sun. It's very important that you put in the 660 for that and not the 750 and not the red shifted value. And then we put the difference over that. Gives us a Z parameter of 90 divided by 660, which is 0.136. The 3 and the 6 are reoccurring there, but we can just round that to 0.136. Now, what we can then do is once we've got the Z parameter, we can use that to calculate the recessional velocity. Because if we look at that equation, the ratio for the Z parameter is also the ratio for the velocity. So Z is also equal to the recessional velocity divided by the speed of light. Putting in our values gives us 0.136 is equal to V. Speed of light is 3 by 10 to the 8. Gives us the recessional velocity, the speed that galaxy is moving away from us, is 4.09 by 10 to the 7 meters per second.